Today we're going to talk about populations. How do they change over time? A population is a group of individual organisms that occupies an area and shares a gene pool. What is a population and how is it measured? A population is a group of organisms that belong to the same species living in the same habitat at the same time. All the individuals of a single species that inhabit a particular area make up a population. All the black bears living in Cook Forest in Pennsylvania make up a single population. Population growth is how the size of a population changes over time. To calculate growth rate, we need to know the birth rate and the death rate. A negative growth rate means that the population is decreasing. A positive growth rate means the population is increasing. Population growth may also be affected by people coming into the population from somewhere else, known as immigration, or leaving the population for another area. That's called emigration. Look at the diagram. Notice that two factors that increase population are births and immigration. Notice that two factors that decrease population are death and emigration. Two important measures of a population are population size, which is the number of individuals, and population density, which is the number of individuals per unit area or volume. The organisms in a population may be distributed in a uniform, random, or clumped pattern. Uniform means that the population is evenly spaced. Random means that the population doesn't have a clear pattern. And clumped means that the population is distributed in clusters. Exponential population growth occurs when resources are unlimited and the population size increases at a rapid rate. The graph below shows a period of exponential growth that aphids experienced. Aphids are small insects that feed on plants. The best example of exponential growth is seen in bacteria. Reproduction for many species takes about an hour. If 1,000 bacteria are placed in a large flask with an unlimited supply of nutrients, after 1 hour there will be 2,000 bacteria. In another hour, they will double and there will be 4,000. After the third hour, there would be 8,000 bacteria in the flask, and so on. After 1 day, the flask would have a mind-boggling 16 billion bacteria. The important concept of exponential growth is that the population growth rate is accelerating. It is increasing at a greater and greater rate. We are witnessing this with the coronavirus. In the real world, resources are limited. Limited resources, or limiting factors, are any living or non-living resource, such as food, sunlight, or nutrients, that limits the size of a population. Logistic growth of a population size occurs when resources are limited, thereby setting a maximum number an environment can support. In the real world, with its limiting factors, exponential growth cannot continue on forever. When the number of individuals becomes large enough, resources will be depleted, slowing the growth rate. Eventually, the growth rate will level off. This is called carrying capacity. It is the maximum number of individuals an environment and its resources can support. If you look on the graph, the horizontal line that goes across the top and through the little squiggly part is showing the carrying capacity of those cells. What factors limit population growth? I gave you a couple examples on the last slide, but on this one we're going to talk about some more. Limiting factors control the growth of a population. Some of the limiting factors are available resources like food, space, and mates. Other things like competition, predation, parasitism, disease, all can affect the population size. Natural disasters and unusual weather can also control population size. Limiting factors determine the carrying capacity for a species. Some more limiting factors are environmental changes like drought and other species, predators, prey, competitors. So take a look at this graph below. It shows an example of a lynx and a snowshoe hare. And take a few minutes to look at the prey and the predator and their population sizes and how they fluctuate and how they relate to one another. How is the human population growing? This graph shows from 5 billion years ago to 2100 what the human population looks like. If you take a look at the graph, around in between 1000 and 2000 AD, there's that little dip there that shows the Black Death, the plague. You can see that the human population dropped there. Then we went into a period of exponential growth. I'm guessing that this graph means that around 2100 we should reach the carrying capacity of Earth, and the human population will level out then. Here are some of the factors that contributed to that exponential growth or that explosion of population size that we saw on the previous graph. Fertility, infant mortality, and longevity are three of the factors that contributed to it. Animal domestication and agriculture provided for a few to feed the many. And the Industrial Revolution saw the growth of cities and infrastructure. Things like water and energy and transportation were easily available. There was also increased productivity, nutrition was better, and sanitation improved. All of these factors helped humans increase their population size. How are humans affecting the environment? Well, here's a list. Limited resources, land, food, and water. Agriculture. industries, ecosystem goods, renewable and non-renewable, desertification and deforestation, water pollution, biological magnification, air pollution, acid rain, habit fragmentation, and introduced species. There's a few of these on here that I'd like to get into in more depth. I hope that we have some time. I know that some of the activities and some of the things that I already have planned include these topics. So we will be exploring a little more how we affect the environment.